we are the University of Dayton Game Development Club. I founded this club with a couple of friends last fall, basically just to get students more involved in game programming and engine development and everything that goes along with it. And we've been trying to schedule talks with cool people to talk about things in the industry, like custom engine development, and in this case, like game physics development. So we're really excited to have you. Would you just be able to give us like a quick introduction?
Yeah, so I've been professionally programming for quite a while. I joined the game industry in I think around 2004 and I got a job at Crystal Dynamics working on Tomb Raider. And so I wrote a physics engine for Tomb Raider Legend, and that was actually on the PS2. So that was my first introduction to like professional game development. And from there, then went to Blizzard. At Blizzard, I was at Blizzard like 15 years, kind of crazy, and um, wrote physics tech for Diablo 3 and Overwatch, and it ended up getting used on most of their games. Um, but I was always working on one of the game teams, so I was always trying to be very close to game development, not just the physics technology.
Yeah, and you did a doctorate in physics related programming, is that right?
Yeah, so I went to grad school and I I wasn't focused on like game physics, but I was focused on robotics simulation and uh, actually, yeah, I did kind of get interested in I would say physics simulation back then. Uh, I had done a what was it? It was some sort of project on the dynamics of a rolling coin. And so I had simulated that and and I was just fascinated by that. I'm like, could we make a game from this? It was probably a bit too early for the game industry to do something like that, but yeah. So I started tinkering with that sort of stuff on the side back then. But
Hmm.
it was some years actually before game industry was ready for physics. It wasn't really until the PS2 where they had the floating point math that I thought it was feasible. Back then in the PS1 generation, they didn't even have floating point math. And I was using a computer back then that it didn't come with floating point math by itself. You had to get it like as an add-on. And I just saw how slow it was and like, okay, there's no way you can do anything real with this. But um, yeah, when the PS2 came around, I was like, okay, now it's time. I'll join the
Yeah.
game industry. But yeah,
I
I got very fortunate there to join Crystal Dynamics at just the right time. That was back when Half-Life 2 had just come out, and everyone saw the physics as part of the gameplay then. And everyone was super inspired. I was super inspired. And so, um, we did similar type of gameplay in Tomb Raider Legend.
yeah. Yeah, that was actually a question I had for you is like I had watched that Half-Life anniversary documentary pretty recently where they talk about how revolutionary the physics were for the gameplay. And I was kind of curious, like, I mean, how do you think real-time physics has changed the industry over the years? And like what are the key points that you've noticed along the way? Like was Half-Life one of them?
Yeah, Half-Life 2 was definitely one of them. It's kind of sad to me in some ways. Like it's not like that's a small fraction of games that have that type of gameplay still. Like you don't just find that. kind of gameplay in every game. You would think that like, okay, we have this technology, we'll just put it in every game and just make games more interactive. But that turns out not to be the case. Um, I think in the 2D space has always kind of interested me because you can make lots of these physics-based games um, more feasibly because they're smaller games. You can just focus on the physics gameplay. When you start to have these larger games, they actually become more constraining in some ways because okay, we have to get the lighting working with the physics. We have to get the AI dealing with it. We have to get our animation working with it. And all these constraints seem to work against having more interactivity. Um, so yeah, I think it seems to be that still like if you want to have good physics gameplay, it has to be part of the focus of the team. You can't just have the one person off on the side on big team making this physics happen. It does have to be a team effort. If you look at um, the Astrobot game that came out recently, that was super inspiring. They did some GDC talks. I was fortunate enough to attend, and I'm sure they'll be available soon, maybe in the next year or something, for everyone to watch. But super inspiring how the whole team was kind of rallied around making this kind of interactive physics gameplay. So yeah, I think that physics, there's always going to be a need for physics in every game because just having a character move around in the world, you need some sort of physics. But if you want physics gameplay, it really has to be a team focus or like a smaller project where that's kind of the focus. Yeah.
Yeah. If you had to pick, like, what are some other interesting physics-based video games that you're a fan of or you think are very important?
I mean, you certainly saw a bunch of games in the early days of the iPhone. Angry Birds was one, and like a lot of and that's when yeah, physics was new and it was in 2D and there was a lot of innovation there. Um, that was great. And then these days you have games like Teardown. Um, love that game. Uh, what else? Uh, kind of in between years there was the like uh, Limbo and Inside. Uh, there was also I'm not sure what they're doing these days, but there was the studio that made Ico, Shadow of the Colossus, and I think it's Last Guardian. That studio did great stuff with physics. Um, I'm trying to think in recent years though, like Astrobot comes to mind. I think it seemed like it kind of physics took a break kind of for like the last few years. It's like, okay, we're gonna work on other stuff. I am excited though that there is a possibility of physics becoming more prevalent in the coming years as dynamic lighting becomes more common. Like you see that with Unreal. For example, they have Lumen, which can handle like, okay, yeah, this wall just got destroyed. Okay, now the light's going through here. The capacity is getting there. You know, like when I worked on Diablo 3 and Overwatch, the lighting was pre-baked. So if anything was too dynamic, it would like the lighting would be messed up and there's all kinds of weird problems you get in games like those. Like, okay, yeah, this zombie got ragdolled and broken into 10 pieces, and one piece is way over here, one piece is way over here, but it's getting the lighting from like where it thinks that the actor or the entity is, and so it's kind of messed up. Um, those kind of problems. Lo- You wouldn't think about that the lighting in 3D games at least can be kind of constraining about what you're doing with physics, but it ends up being that way. And then also another problem with physics, right, is there's so much emphasis on multiplayer these days, and dealing with networking of physics is pretty tough. Like in Overwatch, most of the physics was a lot of it was not part of the gameplay because they didn't want to network it. You would see a lot of like you have your starting rooms where there's a bunch of stuff in there, but it's not like in the main combat space. But then stuff in the main combat space, you would have like lots of breakable railings. Those those would be kind of eventually they just kind of got removed from the gameplay almost. Because yeah, the networking burden, the burden of okay, we have to update now we have to update the navigation data for AI type things on the server dynamically as these things are changing. Uh, so actually the only in that game the only things that actually got networked were like there was like a soccer ball or a basketball. There's like one object in the entire map
Yeah.
that's networked. So yeah, lots of constraints. So I think I think you're starting to see with the networking more, there's more people generally have more bandwidth now, so you can do more with physics. It's the thing is you just still have to deal with the latency some way. So you have to um it comes into your design, like how important is the latency? Like if you're doing a driving game that's networked, right, the latency is super important. But if you're just I don't know, blowing up a building, like if there's some delay in that building reacting, that's not as big a deal. Um, yeah.
Yeah. Wyatt, did you have a question?
Yeah, so like kind of a follow-up with like when you were listing like certain games that have physics and like w the ones that stick out to you. So like what aspects of those physics in those games really pops out to you to say like wow, that's a really good game that has really good physics.
Yeah, I mean, if you can just go back to Half-Life 2, it's where the physics is part of the gameplay, and you need to understand how the physics behaves in order to progress in the game, or you have to make use of the physics in some way, and you're kind of engaging with it, and it's not just background kind of eye candy. Um, Certainly, background eye candy can be a lot of fun, like seeing ragdolls flying all over the place or whatever. That can also be a lot of fun. But I really do like the physics puzzle aspect. That's what you saw that a lot in the 2D games where like we could just make our game is physics puzzle. This is a physics puzzle game, for example, and that's where the quality and the behavior of the physics becomes vital because it controls how the game is played. Whereas if you just have a rag doll flying around, like, okay, that's cool, but it's not, I'm not really having to engage with that as a player in a lot of cases. So yeah, I think that's my feeling about that.
Yeah. I wanted to go back a little bit. to when you started at Crystal Dynamics, when you said that the timing was right for game physics. I was curious, like, what was your experience throughout those days, and kind of what was the state of game physics? Is there stuff that we take for granted now that was not so prevalent back then?
Yeah, absolutely. Back then it was kind of a lot different. And this is why you see that um, I'm like kind of known for Box2D and all these things. All these things were kind of born out of kind of a struggle back then. Um, when I joined Crystal Dynamics and was working on game physics, like it was the physics technology at the time was mainly proprietary, and the ways of doing things, the ways of writing these solvers, the techniques, the technology, it just wasn't known. Um, a lot of the things that you would find uh, in researching these things were not actually appropriate for games. These are things that maybe were used in the film industry, but the techniques were not nearly performant enough to be done in real time. Uh, you know, solving large matrix equations, nobody's going to do that in a game. In a game, you can't do that. Um, Definitely not back in the PS2 days. So it's kind of interesting that yeah, when I joined there, I was yeah, okay, write a physics engine for us, Aaron, and like, okay, I can collide two boxes. That's not too hard. We the the way of doing that kind of thing was well known, but like stacking a few boxes and having the friction work, like n- how do we do this? We don't know. Like, uh, people back then they would write physics simulations, and if you tried to stack boxes, they would just kind of jitter around, jiggle, slide around, and then fall over. And like, I'm like, I don't want that. I want something that, you know, looks good. And you could see that in Half-Life 2 that they had things stacking on each other and behaving fairly nicely. But this was proprietary technology. And I'm not sure why I think so. I don't know. Yeah, maybe Crystal Dynamics, for whatever reason, they didn't decide to license a physics engine. I actually don't remember the reason, but I think they thought that maybe I could do that. So a lot of the work there was actually experimenting and reading and diving through news groups and seeing what other people like. There were just the tiniest nuggets of information here and there, just like a whisper of like, okay, maybe you could try this and it would be better. So I, as much as I could, I tried to gather information, but then I also just had to just kind of beat my head against the keyboard and figure out how to make a lot of the stuff work. And then once I found out that like, okay, this technique seems promising. I don't like this proprietary thing with um, game physics technology. I went to grad school, and that's like people do research, they publish papers, they share the information. That was kind of my mindset. And like, okay, I was like, oh, cool. I figured out how to stack three boxes in Tomb Raider, and I gotta publish this so that other people can benefit, and we can get away from this proprietary thing with game physics. And so I wrote a paper for the GDC. I thought the game developer conference was like a academic conference. So I wrote it like as if I was a grad student writing a formal uh article that might be published in some journal. And I submitted that to the GDC, and They're like, nah, no, you can't do a presentation like this. This is just pure math, and like nobody, we don't do that. But they had this thing with poster sessions there. So I did a poster session. Um, and I had made my article available. The poster session actually got quite a bit of information or attention. It got quite a bit of attention. I was surprised, and because it did show a technique there that you could implement for games, and people were interested in doing that. And still to this day, that paper that I wrote for there gets plenty of attention. It's kind of surprising to me because it's kind of outdated in my opinion. Um, but then after that poster session and attending the game developer conference for the first time, going to some of the talks and like, I'm like, oh, okay, this is what the game developer conference is about. It's more about doing things intuitively, explaining things that are more visual, uh, you know, it's more about PowerPoints. It's not about writing something with a lot of formulas and math, uh, which was what I was used to. So the next year, 2006, I was like, okay, I got to make this like easier to understand. So uh, my idea there was like, okay, I want to do a presentation on how to do 2D physics in the simplest possible way that still has like the essence of what a reasonable solver or simulation would look like that can stack boxes, that can do the Half-Life 2 style physics. And I'm just going to write some example code to go with this presentation. So this for 2006. And so I wrote this very minimal, non-optimized, but it actually had good results. This tiny little engine, and I was like, okay, I'm just gonna do boxes. I'm gonna keep it super simple. So I was like, okay, I'll call it Box2D, and so it was just part of that tutorial there, and it was like 200 lines of code. And like, okay, cool, I'm done. People can take this, they can write their own physics engine. It's no longer a big secret wrapped up in proprietary things. It's simple enough that people who didn't go to grad school and who don't, didn't study advanced math, they can do this. It's just applying impulses and it's very visual and all that. And so I thought I was done, but then people said, "Hey, can you add another feature to this thing? Can you add, circles? Can you add more constraint types?" And then I saw people actually started making games from this small 200 lines of code, like this Crayon Physics game came out. And within like a couple years, and then like the iPhone had just come out and people were like itching to make these kind of physics games on the iPhone. And so like, yeah, Box2D just kind of took off from there. I didn't intend to um, for it to be that way, but then I realized, well, what actually happened was I was working at Blizzard, and it was kind of funny because yeah, at Blizzard I was gonna I got hired to write a physics engine. The project got canceled. I went to Diablo 3. They're using Havoc. I'm like, okay, cool. I'll just integrate Havoc. And but then I realized, hey, I I'm still trying to learn and evolve my toolkit as a game physics programmer. I didn't want to stop. Um, and so I decided, well, I could just do a lot of this technology. I could just develop it all in 2D. So I just kept working on Box2D on the side and building my knowledge and testing things out and getting feedback from people. And so that's why, yeah, I just kind of continued development on Box2D for a while there, and in the late 2000, yeah, 2008 and around that time. Yeah, so it kept evolving.
How did you go about like integrating community feedback and bug reports at the time that it kept evolving? Like, were you prioritizing things that people were saying like this is really important, or was it mostly like a learning process for things that you were interested in?
Yeah, I, that's a good question. I initially thought of Box2D in two ways. One, it was I still felt like, okay, this is something people should learn from, and it should also be something I can learn from, and so it should just be like a community learning center. Even though I knew lots of games were just going to be made from it directly without really people going in and like refining the algorithms or whatnot. Uh, so yeah, Box2D was never really meant to be like super optimal or you know, um, I mean, back in the day when Box2D came out, it was all everyone was single core, and it was I mean it was way faster than any academic method like with matrices or whatever. Um, but I didn't I didn't spend a lot of time like running it through profilers or trying to optimize it in that way. I really did think of it like, okay, this is something where I can develop technology in 2D, and then eventually I started writing physics technology in 3D at Blizzard. And like, okay, I can just develop this technology in 2D. It's much easier to develop algorithms, to test them, to validate them uh, in 2D, and then bring them to 3D. Another thing that's kind of an interesting side effect of it being open source is, yeah, people were using it, they were finding bugs or issues or missing features. It was a lot of good feedback there. So I was fixing things and I was able to bring that to 3D at work. Um, People had ideas about like, okay, well, if I use it in the game like this, then I have this problem. I'm like, oh yeah, I will probably have that problem too. I should go fix that. So I was also kind of a customer of Box2D in a way because I was bringing that technology to 3D. So
How did it feel seeing like the reach of Box 2D? I mean, I know you mentioned Angry Birds earlier, and from what I was reading online, Angry Birds was based on Box 2D, the physics.
yeah, it was pretty incredible. As a programmer, I felt like, the more people that can engage with code that I've written, the the more kind of successful in a way I am as a programmer. Um, so having that happen was amazing. Um, and I did feel like I was at that point kind of like the enabling a lot of 2D physics gameplay, and I wanted those games to be good, right? I wanted them to have good 2D physics. So I did spend quite a bit of time trying to make sure it had a good quality. Like Box2D version 2, I added continuous collision detection, um, which I felt was very important for games and these puzzle games. So, features like that I was adding to kind of help these 2D physics puzzle games and whatever was going on with on the phones at that time. I mean, there was web-based games too. There was this game, Fantastic Contraption, that was really took off. I'm not sure if that was just web, but yeah, people had ported Box2D to like JavaScript and Java and all these places. And yeah, I was eager to make sure that you know, they were creating quality experiences. Yeah.
So how did you balance, I mean, spending your time on Box2D with your time at Blizzard professionally, and even to this day?
Yeah, that's kind of interesting. I've been thinking about that in recent years. Like, how did I do this? I seem to be like a strange person in a way that I can just program from sunrise to sunset. I didn't realize that other people can't do that until recently. Like, uh, so I could work like, especially like if I'm not doing physics at work. Like there was that time where I was just dealing with Havoc. I'm not writing the physics technology. If I could in the evening or in the weekend, I could, oh, now I can work on this other thing. That was very exciting to me. So yeah, I, I don't know. I guess I just program a lot. And, um, so and then I guess when I started developing the 3D technology, the physics engine at Blizzard, which is called Domino. It's still there. I don't work at Blizzard right now, but yeah, it was always like, okay, let me develop this in 2D first. I would do that on my own time, but I would have like I could think about it during the day and then like come up with strategies and then then implement things in the evening or weekend. Um, but I mean, when you have your own like little physics engine and like every part of it, it's also kind of efficient to work on it. Like I can get things done very quickly. Like my day job right now, I work in Unreal, and I just like, okay, getting something done in Unreal can take so much longer than just doing something in my own little code base. Like currently, Box2D, the entire engine compiles in under a second, and I could just iterate so quickly in there. And yeah, so um, yeah, so I would say that I'm also just persistent, I guess, is another thing is a lot of people they'll have like this side project and this side project and that side project, and then like they just get this big backlog of all these different side projects that they don't finish or they yeah. Whereas like I think I need more side projects actually. I think that's actually one of my things. It's like, okay, I got to get to a certain point with Box2D where it's in good shape and my other projects, and then I can work on my own game on the side. But that hasn't happened yet. So I feel kind of bad about that I have not I've not written many games. I've done lots of samples and things with Box2D, but I haven't actually like shipped a game on Box2D. I feel like I'm kind of like Unity, where like they never shipped a game on this thing. But every time I go to do that, it's like, well, I need to. People really want this feature, and I think it'd be maybe useful for me to have in my toolkit. So I'll just work on that. And yeah, so I'll just keep coming back to Box2D, I guess.
Yeah. Dan, did you have a question?
Yeah, so Hi, I'm Dan.
Hi,
Nice to
Dan.
meet you. I'm really happy you're here. Uh, I want to, so since you're just talking about personal projects and things like that, you work in Unreal. So what's your opinion on nowadays a lot of developers will go to Unreal or Unity instead of making their own proprietary engine, at companies or maybe just personal engine for education purposes. What's your opinion on that? I'm a CS student. Should I make my own game engine? Is it worthwhile?
I
Or,
think every pro, yeah. Um, I think every programmer should have some side project, some environment where they can build and learn technology, and evolve it over the years. I think most programmers do that. And then when it comes to like studios and what technology they choose, um, I think that one's pretty easy to answer. Like, and I can reframe that question. I've gotten this like back when I worked at Blizzard and I was writing a physics engine there. People would often come to me and say, "Hey, why are you writing a physics engine? Why don't you guys just use Havoc? Why are you doing this?" And I'm like, I thought about it a lot, like, well, there's advantages and this and that. But at the end of the day, it's like, well, it's because we can. It's because we can. So like if you can write your own engine and you have the time and the people that know how to do that, I think you should. Um, but if you're time constrained, you don't have all the people you would need to do that, then okay, yeah, you probably got to start with something else. But if you're just like, hey, I want to make a 2D block, breakout game, you should write that yourself, I think, as a programmer. Don't like why would you get Unity? You're not what are you going to learn from that? Maybe you learn how to use Unity. Maybe it's like uh maybe it's a good way to get an introduction to Unity, but like if you just want to learn how to make a breakout game just as a general concept itself, you know, just just maybe get something like Raylib or SDL or whatever if you don't want to deal with the platform stuff, but yeah, just write it yourself. Maybe hook Lua up to it or figure out how to script it or something like that and audio and all that, and how all those pieces come together. I think you should do that yourself as a programmer. But if you're going to make like a big game that's supposed to have great graphics and like you should probably look at your team and say, well, does our team even have the capacity to do this? If it doesn't, then yeah, probably start with some other engine. It's kind of interesting. You can also, I wish, so I wish that this would be more like my experience. So let me go back to Crystal Dynamics. At Crystal Dynamics, I was responsible for writing a physics engine for them. There was an open source engine at the time called ODE or Open Dynamics Engine. It did not have the kind of stable simulation that you would need for Half-Life 2. It was very, at that time, maybe it is today, but at that time it was adequate, but it was not something I would want to ship. So what I did was I integrated that and then I just replaced it bit by bit until it was gone. I wish that game studios could do that. Like I would, I wish that people were more like, okay, let's just get this technology base for our game. We'll get things going. We'll get people working, but then we're going to um, maybe take ownership of the entire code base and bit by bit optimize or replace or implement the parts that you like. Like you could do that with actually, I'm not sure if that's feasible to do with if you start for something like Unity, there's no way you're going to replace that bit by bit, or Unreal, there's no way. I wish there were more kind of game frameworks that like, I don't know, maybe encourage that kind of process so that people can take more ownership of their code. It's kind of frustrating to me where like people are just like, okay, I just get this thing and I can't even, like with Unity, it's closed source. You can't even go and fix things. You have to go wait for someone else to fix that. I really don't like that. When I was at on Diablo when we were using Havoc, it actually, by the way, we didn't ship with Havoc. We actually swapped over to Domino, by the way. So that was another thing where I swapped out the technology. But I found it super frustrating that Havoc was this closed source thing. I'm like, I see this bug, I want to go fix it. I want to type the code, but you can't. Like, I think that's pretty sad when people are just like given a technology and they can't engage with that and fix things or change things or modify it. Like that to me is I don't consider that like proper game development. Programmers got to program, right? Like that's just counterintuitive to me.
Yeah, that's really interesting. And during your time at Crystal and Blizzard, would you ever say you were very stressed? Would Because I've always heard that there's a lot of deadlines at in the game industry. Deadline to get this thing out, release date. We got to get this done by that time. Have you ever felt very stressed working with your team? You know,
Uh, it's kind of interesting. I feel like pretty fortunate that in the game industry, back when I started, you did hear about, oh, the game industry is all about crunch and people are just working endlessly. And I never really experienced that kind of crazy crunch, like you have to work 7 days a week type of thing at all. There might have been a couple times when like people were working on a Saturday or whatever. Um, but yeah, I never experienced that. Even at Blizzard, I think either I've been super fortunate or it's just kind of like been kind of maybe it's rare. I don't know. That definitely people have experienced that. In terms of stress, I think you can get the same kind of stress in any job where it's kind of like, am I meeting the demands of the project, right? Like, hey, I can't stack these 3 boxes, they're jiggling. Like, that's kind of stressful. Like, but it's to me, it's like kind of what do you do with that stress? Do you use that to, you know, energize yourself to like, okay, I really care about this problem. I really want to solve this problem. Or is it just like, oh, this is too much. I have to step away. Well, I've always been kind of like, okay, those stressful things, I actually find those as motivators. They actually set a fire in me. I'm like, it's good for me to have that kind of stress. Like I need to like feel like, okay, I need to have this challenge and I want to solve it. Like I'm committed, I'm driven. I want to solve this problem. So, but yeah, I mean, other ways, but at some point, yeah, it may seem like, oh, this is just so overwhelming, and there's no way I can solve all of this. What I recommend to people is, just divide and conquer. Solve the piece that you can solve, then go to the next one, then go to the next one. You have to be comfortable with that as a if you're a person, if you want to push yourself forward and solve problems that you don't know how to solve, you have to be comfortable with like going in there and understanding you're not going to solve it all at once, but maybe you can solve it bit by bit and maybe by the end you'll get there. So definitely how you deal with that stress is important. Now, if there are things where things can be stressful in other ways in a game team where it's like this team is just making the wrong decision, right? And there's nothing you can do about that. And you feel like, okay, I'm in a bad situation, right? Yeah. And that's gonna happen. That's gonna happen to everyone in their career. Like I don't think that's avoidable. Like you just feel like things just are not going well. And like in particular in game development, like game projects get canceled all the time, right? They do all the time, or things don't work out well. What I the what's kind of interesting as a programmer to keep in mind though is like, and I th- and I think it's true for other people, but like in the other areas of the game industry, is like as a programmer, it should be about, well, what did I learn, right? What did I learn working on this project? Am I learning something? Am I okay, maybe it's not the best project, but I'm growing professionally. I'm learning more. If you get into a spot where you're like, okay, the project's bad and I'm not learning anything, get out of there. But like if you're like, hey, I'm not sure about this project, but I'm learning. I like the people I'm working with. That can still be a good experience, I think. Yeah. So, but other disciplines can be like, think about these artists, like they did all this work and it's just gone. It's like on some hard drive somewhere and no one's ever gonna see it because the project was never announced or that can be kind of sad. But as a programmer, you can kind of, even if you're in a, well, it depends, but you can always take the knowledge forward. Sometimes you can even take the code forward. So we at Blizzard, I worked on this project called Titan, which was going to be this MMO. And I think I worked on it 5 years or so and it got canceled. And but then that code it took forward and that became Overwatch. So it was all kind of worth it in the end for me as a programmer. Yeah.
But that's really cool. Actually, there's a book that recently came out. You probably heard of it, called Play Nice. I've heard of Titan and how the development kind of came about, and how it, like after like 7 years or sometime it eventually didn't release. But that's really cool. You worked 5 years on Titan. That's crazy. But during that your time in the industry and working on your team as a physics engine, I guess, maker, did you work on an engine team? Did you have your own engine team and then like another team? I'm not familiar with like a lot of the I guess industry and how it's set up. Could you explain a little bit about your maybe your team at Crystal, maybe and how it differed from Blizzard, and how your team differed from other teams, and how it all came together into one huge game?
Yeah. Yeah. So team structure and all that, and how the technology comes together. It's a good question. Back in the days of Crystal Dynamics, there was no like off-the-shelf engine that's game engine that you could really use then. So everyone was like, okay, we're going to write a game. Well, we need an engine. And the engine at Crystal Dynamics had evolved there over several years from other projects. Like they did like the Soul Reaver games and other things like that. And then they evolved that technology for Tomb Raider. And so there, um, that game engine was um, developed by the game team for that project. So that's how game engines historically have been developed, is they've been developed for a specific game. and not trying to be super general or, they're not it's always like project to project, like, okay, this project, we have to make these things work. We're not thinking about like, oh, how do we generalize this engine to be ready for the next project, after that or whatever. Uh, Certainly you want to have like good tools and things like that as much as possible. Yeah, it's funny how game tools, that's to me almost the most interesting thing, is just to look at how these different teams over the years in the industry have these different tool sets. Um, that's a big topic by itself. But yeah, Crystal had its own tool set and that evolved a lot over the years. But it's all, yeah, written custom for that game. And when I went to Blizzard, the Diablo team, they had their own game engine that evolved from Diablo 2, and it was written specific for that type of game. But then the physics engine is a bit more generic. It can kind of fit into different games. It has to be integrated. There's a lot of work there, just bringing the two things together and making that work well. And then like you need tooling to like, okay, we want this breakable barrel. How do we alter those things? How do we connect those things to the physics engine? There's just a lot of work there. And then uh and then yeah, Titan and Overwatch, they had their own game engine technology, and it was all just for that team, as part of that team. I'd say historically that's how game development has been. I think, yeah, these days you're seeing more teams just using Unity or Unreal, whatever. But historically, that's what I'm used to, is they, proprietary technology. And you did see like, I never was involved with this, but there were companies trying to share technology of their own. Like at Electronic Arts, they have their Frostbite engine, which they try to use across several game teams. Uh, I think there's been other studios that do that sort of thing. It's that that can be very challenging, but it's hard to say if that's better than not using Unreal or not. I haven't been in that situation. Does that answer your question?
Yeah, that's good enough. No, that was really cool, very insightful. Um, yeah, because how did your uh, what experiences like through your PhD would you say really helped you uh once you graduated and got it? How did it really set you up for your career, do you think?
Yeah, it's kind of interesting. I did the grad school um not because I was interested in a specific career. I was interested in the knowledge, and uh it was stuff I wanted to learn. And I felt like when I was doing my undergrad, like at the end, I was like, hey, I want to learn more. And so I'll just go to, and then like, I think, yeah, the end of my undergrad, like the, I did undergrad in mechanical engineering. And I think like when I finished my undergrad, mechanical engineering in the industry was in a rough spot. So like, okay, I'll just keep going. I'll go to grad school. And, but then in grad school, it's kind of, I did feel like it was very valuable. Yeah, I learned a lot of math and stuff that I still find valuable to this day. And um, so that was good. But then also just like, how to work on difficult problems kind of independently, and how to work through a problem that maybe it's going to take you several years to work through. And how do you, like back then, it's kind of interesting. Like, if I wanted to learn something, I needed to go to the library, like, or to find information. Like, there was no Google then, so like you had to fight for the knowledge. So I'm used to like really struggling to find the knowledge, and so yeah, so I think like that experience did help me a lot with like learning to deal with difficult problems. Yeah.
Yeah, that's really interesting, especially for someone for me who's, gonna graduate in a couple years. You know, our experiences are gonna be so different. And so that's really cool to hear what you're how you kind of grew up into it. But thank you for answering my questions. I'll open up for other people now.
Sure.
Thank you.
Yeah, that was awesome. I was kind of curious, Aaron, when you touched on leading the Domino team at Blizzard, like, were there any unique considerations or constraints that arose for the engine based on certain products? I remember reading somewhere that Overwatch had a really unique bone structure for the characters.
Interesting. Yeah, let me think about that. So we did, so yeah, so the Domino, it was integrated into Diablo 3 and then Overwatch. It was also used on WoW. Um, there weren't not too many different constraints. The thing I did, what I did, there were some things which I found patterns, which like, okay, yeah, this team is doing this team is doing this. Can I make it easier for them to do this, or how can I deliver the technology to them? It was kind of challenging because each, like I said, like with Diablo, like, okay, you want this exploding barrel, so you have to make this authoring process. How do you get the information to the physics engine? Well, because at Blizzard, every game team had their own technology. They all needed their own kind of tooling, their way of getting that information to the physics engine. So what ended up happening a lot was just I would be like an advisor for those teams, like, okay, let me see your tooling. How do you edit things? Okay, yeah, this is how you can integrate this technology. That came up with the in later years with the claw simulation. So I worked a lot on claw simulation. That's used a lot in Overwatch. They use that in Diablo 4 a lot. And cloth is very difficult to author nicely. So I worked with their technical artists. So technical artists, if you're a physics programmer, you end up working with technical artists a lot because those are the people that know how to work with tools like Maya or whatever and get the data to the engine. And they set up those workflows for artists to create that content and then get that to the engine. So mainly, yeah, I would say a lot of the problem solving there of dealing with the different game teams was more about like helping them develop those workflows, working with their technical artists to to establish those workflows more than the physics engine itself. There was a bit with the physics engine where it's trying to support there were things like uh, we called them partial ragdolls, but it's kind of like cloth, but it's more suitable for rigid body simulation. Things like long ponytails, or if you want you're holding this weapon and something is kind of hanging off the weapon. A lot of these kind of cosmetic things end up getting used quite a lot. So they integrated that stuff into World of Warcraft, and it turned out that the way they were using it, like the physics engine wasn't optimized for that. So there were things where like, okay, yeah, they're using this feature a lot. Like maybe they have hundreds or thousands of these things, whereas on this other project, they only had like 10 of these things. And okay, so I need to do something to help kind of optimize for that usage, but it wasn't. I'd say there's a little bit of feature requests here and there, but most of them were pretty general. Somehow it is with a physics engine that you can write it in a fairly general way, and it can be used for a lot of different situations. Yeah. Let's see if there's anything more to say about that. Yeah, that's the other thing I think people don't realize. If you're in like AAA as a physics programmer, it's not just enough just to have a physics engine or to integrate the physics engine into the game engine. To really get good content in the game, you need to be working with the technical artists, with the artists to get that content into the game. You need to review that content and make sure it's set up well and has a good results. And they're thinking of like they don't know how a physics engine behaves, so you have to help them provide good guidance. I did a presentation at the GDC on how we authored ragdolls, for example, in Diablo 3 to get good results. And yeah, a lot of that were things I learned, but then when I would learn those things, I would communicate them to our technical artists. So like the technical artists would be, they the they often call them riggers, people who set up the skeletons on the meshes. They do the rig. They basically bring animation to the meshes that the artists create. Those people also tend to set up the ragdolls, set up the collision, the joint constraints, all that stuff. And that's a skill. Like to author good ragdolls, that's like a skill unto itself. If you want them to look good in a game, and I see lots of games where they don't look good, and like okay, yeah, they it's hard. Physics engines don't always behave the way you want them to behave. They're just, they're just doing it's fully procedural. You don't know what you're going to get. So you have to it's kind of interesting. It's kind of like the chatbots these days. If you give a bad prompt, like you get bad results. It's the same sort of thing. Yeah.
Yeah, I mean, you mentioned like physics engines not always behaving how you want them to behave, and it makes me think of like deterministic versus non-deterministic engines. Has that ever been a consideration on anything you've worked on?
Yeah, that was something that was pretty sad for me and this gets back to the networking, like on Overwatch, the ragdolls were client side only. So what would happen, and I think it's still this way probably, is you in that game, you see some ragdoll that does something, but then they have these replays or these kill cam things, and where they're going back and then they're showing the thing over again. Well, the ragdoll's different every time because it's not deterministic, it's not networked. Yeah, so that's unfortunate. In terms of like determinism itself as a concept, I really like it because as a programmer, it makes debugging a lot better, and it's also even for if you're developing content, if you can do the same thing multiple times and always get the same result, then you can kind of tune things and develop more effectively. People also tend to think that if they get determinism, that will help them with making network games. I think that I haven't seen that being terribly successful yet. Like, so if you look at RTS games, those are fully deterministic and they're peer-to-peer. Typically, like a game like StarCraft. And the way they work is, okay, everyone gets their inputs sent to everyone else, and then they all march forward. Then they go to the next round. All the inputs get sent out to everyone, peer to peer, and then they all march forward. And then that has to be deterministic. You could definitely do that with physics. Like you could definitely, like, if you had physics in your game as deterministic, you could make an RTS with physics. I I wish I did that I think that is like an opening that no one has really taken advantage of with deterministic physics. Um, I think like if you looked at StarCraft back in that day, it was hard to get deterministic floating point. So they did fixed point math. But these days with the processors have evolved where if you write your code and you set up your compiler just right, you can do floating point deterministically. So you could make an RTS game with real physics that's deterministic. But then if you want a game that's like latency sensitive with physics, that's going to be really hard because you don't want to wait for everyone's inputs. You're trying to drive your car, right? You don't want to wait. Um, so those kind of games, they get better results if they have some sort of distributed authority or some prediction. Um, and as soon as you have that sort of thing, determinism doesn't kind of loses some of its importance, I'd say. I think it's still good to have determinism in your physics engine as a feature, but that doesn't always mean that your game needs that like to ship. Like it's better, but it maybe not necessary. Yeah.
Yeah. I was also kind of curious. I mean, you've obviously had a pretty long and successful career. When you reflect on it, what are you the most proud of?
I'd say like one of the highlights of my career was that kind of like, okay, Titan failed, and then we developed Overwatch like very quickly, and then the we actually developed Overwatch, yeah, like very quickly, and everyone on the team felt really good about it. It was like everyone was like understood like that was a problem in Titan. One of the problems in Titan is like nobody knew what game we're making. Like what are we doing? Like the team's going in 20 different directions. But then on like on Overwatch, everyone's like, okay, I totally get it. I know what we're doing. And so I think we had that game it was like 3 years or something. We developed that game super quick and for AAA at that time, and we we did an announcement for it at at BlizzCon. And what was really awesome about that announcement was nobody knew that the game existed. Uh, we had the reveal trailer, then we showed a gameplay trailer, and then we had like the booze set up where you could go play it. And that was like all at once. Um, yeah, and that was just incredible. That was incredible. I mean, developing a great technology like for a physics engine is really awesome, but being part of a game team that's that's, you know, doing this collaborative effort that, you know, if it's successful, that's super exciting.
Yeah. And obviously, I mean, Overwatch was so huge and people were so invested in it, particularly right when it came out, it changed the industry a lot. Is that like, I don't know, how weird is that for you even to think that nowadays into Overwatch 2, the same physics engine has been carried over and kept going?
Yeah, that's actually not a new feeling for me because at Crystal Dynamics, the engine I had written there, I think that carried on for quite a while. It might be finally dead now, but I think it that carried on for quite a while. So yeah, that was not a new feeling for me. And you know, at Blizzard, yeah, they have Domino, and that's, you know, they're able to use that for whatever games they want. It Yeah, I mean, I hope people enjoy the physics in those games. You know, that was one of the things that was a little bit sad to me at Blizzard is like, oh, everything's multiplayer, so we can't really have like physics puzzles and like physics as part of gameplay. You didn't see that much there. That was a little bit sad for me, but I still think though, like the physics that I felt like the physics you would find in like the Diablo games or Diablo 4, you know, it's very it is kind of cosmetic, but it also feels very empowering. Like you're casting these spells and these things are blowing up and things are reacting to you. You know, you kill this zombie and it flies across the screen, it slams into a wall and then slumps down. I think that's awesome. So I hope people enjoy that. Like to me, yeah, as a programmer who writes that kind of technology, um, for me, it's just I get a kick out of like people enjoying it, like in some way or another. Like like if it makes them smile at some point or whatever, they you know they have fun, they feel good. That's to me is very encouraging. So it's great if yeah, if they continue using that technology and that provides that experience for people, that's great.
Yeah. It's really cool to talk to you about Domino, like particularly because my closest experience with Blizzard physics has been Overwatch. And I think a huge part of Overwatch for me as a player is like when you spawn in the spawn room and there's a million little things you can break and kick around and like you go out if you're like a defender, you go out and you go break every railing and like
Yeah.
watch the whole thing get cleared. So it's really cool. Like I think that kind of thing has like a bigger impact on players than probably you might realize. So
That's great. That's great.
yeah. Um, I was curious, kind of like to bring us towards closing a little bit. Um, are there any like big open-ended problems in game physics or real-time physics simulation that are on your mind?
Yeah, if you look at like Astrobot, they're doing some new things there in 3D. Like they had some fluid stuff, they have some soft body stuff. They have levels where like things are changing, the geometry of the levels changing a lot. I think that something where it's 3D and like just the world is like being modified on a large scale. I think that's a very interesting thing that hasn't could be explored more. Yeah, so I'm hoping that we'll see more of that kind of thing. If you watch the Astrobot talk, it's kind of crazy. Like they're in Maya and they're animating the level. Like things are coming out of the ground, things are just changing in big ways, and you see that like that is updating in real time in the game. Like they have this really cool hot reloading thing. I think that the key to having like these good physics experiences is a lot of it's tooling where you get like this hot reloading things can be adjusted on the fly. If you saw like people talk about this in other aspects of game development, like if you see Billy Basso talk about Animal Well and how he's tuning things on the fly. I guess he had like these MIDI controllers or he's adjusting things on the fly. I think that sort of approach to game physics development could be super valuable. Um, yeah, so those kinds of things I think are exciting to me in game physics.
Yeah. Do you have any advice for those of us who might be interested in getting into game physics in the future or even just game development?
Yeah, so uh, I always recommend to people, to young people in game development, um, first of all, make something that you can show as part of like, artists, they have portfolios. I think it's good for programmers to have portfolios as well. Even though it's typically not as required, it's not like if you apply for a job as an artist, like the first thing they say is, okay, link your portfolio, right? Programmers is not often required, but I still think it's like, oh yeah, here's my GitHub. You can check out my code. Here's a video showing my project. I think that's super valuable, incredibly valuable for programmers getting into game development. And then if you're interested in game physics, the opportunities are not as ubiquitous for that as you might find like for graphics programmer or if you want to be an animation programmer or things like that. Other specialties are a bit more ubiquitous. Uh, I recommend just to get any job you can in game development to get started and then steer into, if you're interested in game physics, see if you can steer into that. Yeah. I think the path I took getting into game physics is kind of unique because back when I started, it wasn't as widely known and it wasn't as big a scale. But somehow, yeah, somehow I got a job as a game physics programmer in my first job at Crystal Dynamics, but it's very rare, I've learned. So, but I've given young people this advice before to just like if you're interested in game development, your game physics, just get a job in game development. And I've known young people who've gone on to do that and that seemed to be like that really worked out for them. And you know, game physics is very interesting, but there's lots of areas to game development that are interesting. I work on animation now. Uh, you could work on AI, you could work on graphics. There's so many different areas of game development that are interesting. Um, so even if you don't get to work on game physics immediately professionally, you can still learn a lot. And by learning those other areas, that would make you better as a game physics programmer.
Yeah. And then kind of my last question is like, do you have any advice for tackling hard problems? Is there anything that you've learned over the years as far as like breaking down problems and approaching them methodically that you think we should be aware of and implement in our own lives?
Yeah, right. So I already mentioned divide and conquer. And then I think another thing that's important is um, be ready to try different approaches to the same thing. Be ready, like, okay, I don't know the best way to do this. I'll try all of them. So keep an open mind that like maybe your first idea is not the best one. Maybe it's your second or your third idea that's better. So um yeah, so be ready to try multiple ideas. Another one is try to if there's any way of visualizing what you're doing, create a visualization for it. Yeah, and really, yeah, try to have that kind of prototype mindset where you're going to try things, you're going to try multiple different things, you're going to visualize them, and yeah, and if it's a big problem, maybe you'll have to do that several times within that big problem space. At each level, you'll say, okay, I'm now at the bottom level. I'm going to try 2 or 3, 4 different things here, and I'm going to visualize that, and then I'll build on top of that. And then maybe you'll have to go back to those other earlier decisions and revisit them. But um, and then another thing that's hard, and that is just like you may not even really know like what what it is you're trying to solve or what you're trying to do. You're just trying to get something going. So there, I have advice is um, grab something that someone else did and then start iterating on that. Maybe it's not the same thing you want, but maybe it will introduce you into that problem space. Grab their code or whatever and to start reading their code and understanding it. That's another thing I think programmers can really benefit from is not being too insulated. Like read other people's code as much as you can. You will learn a lot from that. Um, it's not that like, and you're not saying that like, uh, I'm this other person is just like maybe their solution is not the best solution, right? Maybe you do have better ideas. Programmers can be very proud, like, oh, my ideas are the good thing, or the way I type code is the good thing, or my code style is better. That's fine, but like you could still, even if this other programmer doesn't work the way you like, or what they do, you don't agree with it, you can still learn a lot by studying what they do, because even programmers you don't agree with how they're doing things, they can still have lots of good bits of information and insights that they've developed that you can learn by looking at their code. And a lot of this is not written anywhere. It's just lives in the code.
Yeah, that's really interesting. Well, yeah, thank you so much. It's been awesome to have you and talk with you. We really appreciate you making the time. Does anybody else have any last minute questions before we close?
I don't have any questions, but I just want to say this was a fantastic talk. Thank you so much for coming and talking to us.
Yeah, thank you so much, Aaron.
You're welcome.
All right. Well, have a good one.
You too. Take care.
Bye, everyone.